Security Plus Nugget Series, Network Security Tools. Well, this nugget's going to be kind of an extension of some of the topics we talked about earlier in this nugget series in the first domain of Security Plus. We've already explored the concepts of intrusion detection systems and intrusion prevention systems. We're going to revisit that concept as we talk about the network-based version of that specifically. We've also defined pretty well in the previous nugget firewalls. We'll revisit that kind of as a review, and then we'll look at honeypots. We'll also talk about proxy servers and how they do application caching as well. We'll talk about the protocol analyzer tools that are used as network security tools, and then we'll look at penetration testing. Now, in a previous nugget, I laid out for you the difference between IDS, intrusion detection systems, and IPS, intrusion prevention systems. In large corporate enterprise networks, you have needs for both of these. For IDS, which takes copies of data and then analyzes it in a reactive standpoint, and intrusion prevention systems, which sit in line and investigate traffic as it goes through the wire or through the wireless RF. Now, our networks of today, they're huge and they're complex, and the environment is still exposed and extremely vulnerable. And it's an ever-evolving network landscape. So we need a security solution that's going to provide defense in depth, layered security. So network IDS and network IPS is just another layer of security along with firewalls and IP security VPNs and other tools that provide detailed protection of traffic at OSI layer 2 all the way up through the application layer at layer 7. Now, as I mentioned before, things are rapidly moving towards intrusion prevention systems in the network environment, which gives you that detailed traffic inspection. It prevents malicious traffic, viruses, worms, adware, spyware, application abuse like peer-to-peer file sharing. It's also an inline intrusion prevention, inline ready solution in the line of traffic. You can also combine IPS with promiscuous capture of traffic from switch ports for intrusion detection systems as well. We can combine signature-based, which compares the traffic against a known database of malicious activity, as well as anomaly-based detection, where if there's any changes in the baseline of normal traffic, we see that as anomalous behavior and we can react accordingly. And we have a wide variety of solutions out there, from dedicated intrusion prevention, intrusion detection appliances, to software that you can install on routers, to integrated firewall solutions, to sensor software that you can install on hosts and on servers. So we have all different types of solutions out there from a hardware and software standpoint. So let's say in this corporate network we have multi-layer switches that are connecting our corporate LAN to each one of these different modules. The management module, the extranet for our partners, maybe you have multiples of those, the remote access area, the regional office, branch office, remote office, WAN connectivity area, the data center connectivity, all of this going through distribution layer switches into the core of our network. And then of course we've got our DMZs out here in our security zones providing services out to the internet. You may have intrusion prevention services or IPS devices in each one of these modules, a dedicated device. Or it may be some integrated security appliance like a Cisco ASA device. So you might have an IPS sensor, like a rack-mounted sensor, in each one of these modules that's in line between the traffic coming from our firewall or router running security software, okay, in line investigating traffic that comes from the distribution and core of our network in and out of this management module and from our extranet partner or into the data center and back into the core of the network. We may also in some situations, maybe with an extranet partner, use an intrusion detection service that connects to the switch ports, for example, and it makes copies of traffic and does reactive activities that IDS does. We may have IDS sensors as well out here in the demilitarized zones. IDS in the demilitarized zone is a great idea, and then sticking with intrusion prevention systems and all these other modules. Of course, on these routers, we can also run software that does software intrusion detection and intrusion prevention. Now, the Security Plus exam isn't a design exam by any means. You don't need to know the design aspects of this, but you need to know what IPS and IDS can do from a networking standpoint for your organization. Now, what are some of the things that IPS can specifically do with the traffic as it goes in line through one of these sensors or one of these devices that's running IPS software? And you know, don't kid yourself, this is a software application. Well, it can do a lot of things. It can deny, that's one of the things it can do. It can deny attackers based on their IP address. It can deny attacker services based on the services and the ports they're using, the protocols they're using. It can, if it isolates a victim, it can deny any more traffic from the victim to mitigate against a distributed denial of service attack, for example. It can deny connections, which makes sense. TCP/IP connections. It can deny individual packets that are anomalous or match some type of signature. It can log. It can do logging, and this is more of a IDS type feature, but it can log attacker packets, for example. I'll just put ATTPACK. It can log attacker packets. It can log the victim's packets for later investigation. It can actually modify packets on the fly in line. It can produce alerts which can be sent to management stations, okay, and management software. It can produce a verbose alert, which is actually kind of like doing a dump, all right, a memory dump to a logging management station. It can do requests. It can make requests to block connections and requests to block individual hosts. It can do rate limiting, okay? It can request that the rate is limited on a particular channel in order to mitigate against a denial of service attack, for example. It can also request SNMP trap information. We can use simple network management protocol with our IPS device, and last but not least, it can reset TCP connections. The IPS device will actually send TCP resets to actually hijack and terminate a nefarious TCP flow. Now, as you know, the Security Plus exam is vendor independent, so you're not going to have to understand how to configure an IPS on a Cisco firewall or router or sensor. But while we're here, I've got a 3725 router that's running one of the new security operating systems from Cisco. I just want to show you the way to configure my IPS on my particular router, which is a great solution because the traffic, of course, is flowing through this router as the router routes traffic from one network to another, is the IP inspect command. And IP inspect just shows you, you can see some of the things that we can do with our IP inspect, which is intrusion prevention on this router. We can configure firewall interoperability, for example. We can turn on alerts. Right now, the alerts are turned on. We can configure what are called audit trails to log particular type of information, particular TCP sessions, for example. We can set DNS timeout values to do intrusion prevention on DNS attacks. Here's our logging. Max incomplete is TCP intrusion prevention techniques. We can set TCP and UDP configuration timeouts. Just an idea of some of the things that we can do for IP traffic coming in line through this particular router. We do intrusion prevention on this particular device with the IP inspect command set. Now, I've already talked about firewalls pretty extensively in a previous Nugget movie, so I'm going to go ahead and just hit some high points here, and then we'll define what a honeypot is, which is kind of a cool security feature, and it's kind of a tool we need to know about. Now, remember, firewalls are hardware-based and or software-based. In other words, your enterprise organization could combine hardware firewalls with software firewall features running on servers and routers, for example. So a combination hardware and software solution is what large enterprise organizations are going to use to enforce their network access security policy. So I kind of abbreviated that, our network access security policy. And it should be your first real step towards security. Okay, I put that down here. It's the first move towards defense in depth. Even for the host, you go and you buy that new PC from your favorite vendor, or you install PCs at your organization or your customer's organization. The first thing you want to do is make sure you've got a firewall security suite installed on that system right off the top. Typically, they're integrated firewalls, antivirus, anti-spam, anti-spyware, privacy solutions. Now, modern firewalls that we use in the enterprise will do a lot more than just packet filtering and network access control. They'll do other types of access control, user-based access control. They'll terminate VPN tunnels. They'll provide VPN services like IPsec, for example. They'll provide quality of service with rate limiting and other type of traffic policing mechanisms. They provide redundancy, even intrusion detection and intrusion prevention on modern firewalls. For example, HP and Cisco both have integrated appliances that provide all these features. So you can get total confidentiality, integrity, and availability out of modern firewalls. And again, typically, for a new company, this is your first implementation toward layered security. Now, hardware zone-based firewalls, like I alluded to previously, the zone-based concept of security zones, this is really the superior choice. Now, why are hardware-based firewalls, in my opinion, superior to software-based firewalls? Well, here's the thing. Software-based firewalls, they have an underlying dependency upon the operating system that they're running on. So if you've got a firewall, which is a Linux box, that is serving with firewall software on there, not only is the firewall software a point of failure and vulnerability, it's also the underlying Linux operating system that it's running on, or the Sun Solaris operating system. If you're running firewall software on a Windows 2003 server, okay, the underlying Windows vulnerabilities have to be considered as well. So when you get this hardware-based solution, typically the design and configuration are all built in. They're less vulnerable than software firewalls. Some of the newer models even provide multiple virtual firewalls. So for example, if you have a firewall solution here, what you can have is you can have multiple what are called security contexts. Each security context is actually its own virtual firewall. Now, why is this beneficial? Well, I could have a firewall pointing to my DMZ, and each security zone could be its own dedicated security context, where I could have management of each one of these security zones individually. I could have security zones being their own security context, which is basically their own virtual firewall configuration for individual extranet partners, okay, on a partner-by-partner basis. Or if I'm an ISP, a service provider, I might want to have multiple virtual firewalls, so each one of my customers is its own security context. So these are very, very powerful devices offering all types of security features, including the new move towards virtualization. Now let's talk about a honeypot and define what that is. Honeypots have been around for quite a while, and we associate them with firewalls because typically honeypots are placed out in demilitarized zones at the perimeter of our network, areas that connect to the public internet, untrusted networks, extranets, and the like. A honeypot is actually a trap, a software trap to deflect, to detect, and to counteract attacks and any unauthorized access of our information systems. So in other words, they're put there to actually lure would-be attackers, malicious users, malware spreaders, and spammers into this system away from our production networks, and as tools for counter reconnaissance and investigation of attackers on our network. A honeypot is typically a computer, for example, a Linux server or a Linux workstation. It could be an entire subnet, a range of IP addresses, for example. A honeypot could be tempting and interesting data that's sitting on a computer out there in the DMZ, or it could be an entire site. The goal of a honeypot, though, is to be isolated from our production networks and unprotected to various degrees, depending upon what you're trying to do with it. Some honeypots are protected just to the point to where the malicious user or hacker thinks it's a real production system. We also are going to use the information, we're going to log the information and monitor the information to further enhance security. Now, the downside to honeypots are they have to be implemented very carefully. Okay, if you put in a honeypot system, for example, a Windows server as a honeypot, and it has a trust relationship with another Windows server on the same Active Directory domain, then you could actually exploit that particular server and get to other systems. They need to be implemented very carefully. There's actually tools out there that are like anti-honeypot systems. They actually go out and look for honeypots. So we use honeypots typically in the DMZ area for surveys, for early warning of spamming attacks or denial of service attacks or other malware attacks. We use them for capturing and for trapping malicious users. Some honeypots are specifically designed to counteract spammers, for example. There's a Unix utility called HoneyD, which can actually simulate a large network on one single host as a honeypot. There's other tools like MW Collect and Nepenthes, which are both open standard tools that can be used to autonomously collect spreading malware. These attacks are logged, they're monitored, and information is extracted from the malware binaries to build signatures from for intrusion detection and intrusion prevention. There's also a program called HoneyTrap, which can dynamically create port listeners based on TCP connection attempts that are extracted from a network interface stream. So there's a wide variety of different honeypots out there. They've been there for a long time, and they're not going away. So that is something that people want you to know about. As a matter of fact, if you want to build upon your honeypot and connect two or more honeypots together, then you can have what's called a honey net. Or you can create a centralized collection of honeypots and analysis tools called a honey farm. That's not a Chevy Chase movie. That was Funny Farm. This is Honey Farm. So the honey just keeps on flowing. The term proxy server is really kind of a generic term. It's really a gateway that can provide lots of different services at different layers of the OSI model. You've got proxies that can operate at the network layer, the transport layer, the application layers. By definition, a proxy is a gateway or an intermediary device between two different domains, two different networks, to provide quite a few different types of services. Now, originally, a firewall was just basically a packet inspection tool. It was just basic TCP and UDP filtering. Then it went beyond that to actually do some inspection into the application layer. In other words, it would store the entire packet and reprocess that packet. It would intercept them as it came through a network. That's when we would have the term what are called firewall proxies. Now, almost all firewalls, and I talked about firewalls earlier, all firewalls are basically proxies now anyway. And if you think about the network address translation scheme, the NAT protocol, we talked about that as well earlier. NAT is also a form of a proxy service in the sense that it represents to the outside world some type of public IP address, but it's doing translation on the proxy device into some type of private addressing scheme, either converting a number of IP addresses or sockets, addresses and ports, into one single address, or one-to-one mapping, or things like that. So NAT is also a proxy service. Anything that serves as a gateway. Now, well, we see proxies a lot now. We saw them, for example, in Microsoft's IIS service and other new services that companies provide in the form of web server proxies. Web server proxies and other applications are gateways, and they can provide translation services. You can do language translation, for example, at a web proxy layer. You can do translation using XML. So a web server can be a gateway that does XML translation, translating business logic from one extranet partner into another extranet partner. So you can have that kind of translation service on business servers that are using XML and other forms, other languages to do translation services. Web server proxies will also do caching. So I can have a web server proxy caching all of the web pages that the internal users are surfing to for a couple of reasons. Number one, for performance. I have those commonly surfed pages cached on my servers. Therefore, that cuts down on bandwidth and traffic from my network to the ISP, because we're caching all of that information. So beyond just the caching that's done on the workstation in the browser, we can also have caching done on the web server proxy as well. That also allows us to take those web pages and inspect them and filter. We can inspect them to make sure that people are adhering to policies like not going to adult websites or gambling sites or sports betting sites or poker sites, things that aren't in our corporate policy, things they shouldn't be surfing during business hours. So we can cache the web pages, inspect them, and then we can filter them accordingly. We can also use those web server proxies to filter out things like peer-to-peer file sharing. So it's this deep packet inspection and application proxy features where we kind of got that original firewall proxy concept from, because these web server proxies and other application proxies, they are serving as firewalls. They're barriers between two different domains, two different networks, for the purpose of serving as gateways, as intermediaries, intercepting, storing packets and reprocessing them, translation services like NAT or XML translation, caching, filtering, inspection. That's what a proxy server is. It's a pretty generic term, but it operates at several layers of the OSI model, and they're everywhere. Alright, the next topic on our list is that of protocol analyzers. And protocol analyzers are a valuable tool to monitor your wired and wireless networks, not just for capacity planning and for growth and for optimization and for adherence to security policies and other types of policies like file transfer policies, but it's also a great tool for security, but it's also a vulnerability for security. Now, on my Vista machine, I've got a simple little protocol analyzer. You can see down here my CPU usage. Click on that. I've got my Windows Task Manager, and believe it or not, this is kind of a protocol analyzer in the sense that I can look at applications that are running. I can look at processes that are running on my machine to see if I've got rogue processes or applications running, the services that are running. So this is in itself kind of a protocol analysis tool, a basic tool. You can also see if users are logged onto your system who shouldn't be. So that's a basic analyzer. But a better analyzer, and one that you can get for free, is to go up to the web and go to Ethereal, E-T-H-E-R-E-A-L, Ethereal, and you can get a protocol analyzer called Wireshark. That's their new protocol analyzer, which I'm looking at right here. Now, I use Wireshark as my wired protocol analyzer, and I use AeroPeak, okay, as my wireless protocol analyzer, because this is two different types of physics we're dealing with. So I have to use a separate analyzer which actually goes to my network interface card in promiscuous mode and is investigating traffic, and I can also use a wireless one which can allow me to go through and look at different wireless service sets. I'll talk more about the wireless protocol analyzer in the upcoming nugget on wireless security. Now what we're looking at here, what's cool about this particular packet analyzer is I can go and I can capture information by just saying, I want to capture on certain interface. I can filter out information. I can look at different options. I can go ahead and start the capture. Once I get it, I can go ahead and analyze it, okay, by filtering out what I'm seeing here. And this Security Plus is not for going and learning how this tool is used, but you can see I've got source IP addresses, destination IP addresses, time stamping here. The protocol, which I'm looking at right now, is the messenger protocol. So I'm looking at the messenger protocol that's used by Instant Messenger, AOL Messenger, Yahoo Messenger, and the like. And you can see as we come down here, I'm going to go all the way down from layer 1 all the way up to the application layer. So you can see here's down at the frame layer where we've got our zeros and ones converted into hexadecimal information. And you can see at the frame level the actual bits as they hit the wire. You can go to the Ethernet. Now I'm going down to my Ethernet. So this is an Ethernet environment using Ethernet 2. You can see destination and source MAC address. We move up into the upper layers of the data link layer to see PPP over Ethernet. When I see the PPP over Ethernet session, that tells me this was captured most likely using a DSL connection. DSL commonly uses PPPoE or PPP over Ethernet and point-to-point protocol. So as you can tell, point-to-point protocol sits on top of PPPoE. And then I keep on going up to layer 3. Here's the Internet Protocol. So I'm using IP version 4, 20-byte header. You can see other information, fragment, flags, time to live. This is the UDP protocol that's being used. And of course, I can also know that it's UDP by going up to layer 4, the transport layer. And you can see the user datagram protocol header. You can see the source port and destination port. Destination port being 1027 for this instant messenger program. Keep on going up, you see RPC, we start to get to the operating system now, up into the session layer and the presentation layer. And we move up here to the very top, and we can see here's the Microsoft Messenger service at the application layer. And I can actually see down here in clear text information. And that's why these protocol analyzer tools are so dangerous. These are also called packet sniffers. If people can introduce these applications in promiscuous mode onto my network in my organization, they can actually pull information off the wire for protocols that use clear text. And here's the problem. The protocols that use clear text are very common ones like HTTP, FTP, Telnet, Instant Messenger, and the like. So that's why Instant Messenger warns you not to put credit card information or other things in your information chat window. Other chat programs also clear text. So anything that's in clear text, I can capture this, I can analyze it, and I can pull information out of those packets. So protocol analyzers, packet sniffers, valuable tools, but also a security vulnerability in your wired and wireless network. The last tool we're going to look at is really more of a process than it is a tool, but it is a tool in the sense that it is a useful mechanism for evaluating security, doing risk assessment, and risk management in your organization. It's part of the auditing process. It's part of the initial process of creating a security policy to determine where your vulnerabilities and your weaknesses are. It's called penetration testing, and it uses tools, for example, like protocol analyzers and other tools like hacker tools to try to penetrate your defense systems, to find out if your defense in depth is, number one, deep enough and broad enough and comprehensive enough. You've heard of black hat hackers? Well, penetration testing is done by white hat hackers. These are hackers or crackers who are basically professionals who are hired to come in and find weaknesses in my organization. Penetration testing is the security probing, the testing of systems, human systems, Testing users' vulnerability to social engineering schemes. How they use weak passwords and other access mechanisms. Are they adhering to mandates from HIPAA and Sarbanes-Oxley? Are they using proper physical security? Are they lending their security badge to people, for example, things like that. So you can do security probing of users. You can also probe other hardware systems and software systems. The goal is to seek out vulnerabilities that a malicious hacker or attacker would exploit. The testing process is going to involve a very methodical exploration of all the security features of all systems that are being looked at. Then there'll be a vigorous attempt to breach the security and penetrate the system. So the ethical hacker, typically a third-party person or a consultant, their goal is to think like a hacker. They're going to try to compromise demilitarized zones or security zones. They're going to look at ways to get into the intranet, either from the outside or the inside. They might try to compromise your PBX system or your telephony, IP telephony system. They might want to try to get access to databases that are stored locally on workstations, databases on departmental servers, trying to breach your data center. This can also be part of the regular auditing process, okay? The regular auditing process that's done maybe on a quarterly or a biannual basis. Once this is done, a vulnerability assessment will be put together. This will be a written document, a vulnerability assessment, and this can cost thousands, tens of thousands of dollars, depending upon the size of your organization. But regardless of the size of your organization, if you're a small mom and pop business with computers that are exposed to the network, it certainly wouldn't hurt to find a trusted individual to come in and see if they can use their expertise, okay? Somebody with a Security Plus certification and some experience to come in and try to do some auditing and assessment of your system and try to penetrate your defenses. And again, with defense in depth, with layered security, the more layers you have, the deeper and broader your security mechanisms, the tighter your adherence to security policies, the better configured and more up-to-date your firewall systems, your network operating systems, your servers, your IDS, your IPS, the more patched and fixed and updated and properly configured you are, the better results you're going to have against this brutal penetration test. Alright, in this nugget on network security tools, we revisited the concept of intrusion detection and intrusion prevention, looking at network-based IDS and IPS. We also looked at firewalls again, and we discovered what honeypots are. Again, we got honeypots, honeynets, and the like. Talked about proxy servers, a broad term representing a lot of different types of translation gateways. Looked at a protocol analyzer and talked about the vulnerability that those are to our network. And then finally, a very important tool, that of penetration testing. I hope this CBT nugget has been informative for you. I want to thank you for viewing. We'll see you in the next nugget on wireless security. I think you're going to like it.